Here are the answers for the Section 5-1 homework, starting with the oral exercises. We're asked to simplify these expressions that involve exponents. We have a product where the base is the same. We had this in the last chapter. Write the base and add the exponents together. This makes 5 to the first power, which is just 5. Number 3, we have the same situation. We have a product and we have the same base. So write the base and add the exponents together. This makes c to the -7 power. Now it's unclear in these directions if we're allowed to leave our answers with negative exponents, because one of the main ideas of the section has to do with how to simplify when you have a negative exponent. This is equal to 1 over c to the +7. I'm applying the rule that the meaning of a negative exponent is as a reciprocal. So the symbol for reciprocal is 1 over, and then you fill in c to the 7. Number 5, we have the same situation. So you write the base and add the exponents together. You get a to the m-7. Number 11, same situation. Write the base and add the exponents together. But n plus 0 is just an n. Number 13, we have a division problem with the same base. So the rule was to write the base and subtract the exponents. This makes r to the -8 power. Again, the directions are a little unclear if we can leave our answer with negative exponents or if we're supposed to use the reciprocal rule that we're learning in the section. This is equal to 1 over r to the 8th power. Number 25, we have a power in the parentheses being raised to another power. We learned this in the last chapter. You multiply those exponents together. This is a to the -6. And if you go farther, you would get 1 over a to the 6. Number 31, we have 3 times a to the 0. One of the things we learned in this section was any number except 0 to the 0 power makes a 1. So this is equivalent to 3 times 1, which is just 3. And again, that is assuming that a is not a 0. Number 35, let's simplify this. This is equal to 1 over 1 plus 1. The a to the 0 power is equal to a 1 as long as that a is not a 0. And then this makes 1/2. So the answer is 1/2, but only when a is not 0. Number 37, we have a fraction in the parentheses being raised to a negative exponent. Let's apply the meaning of a -1 exponent, which means reciprocal. Turn the fraction upside down. We get 2 to the 3rd power all over 1. And this makes 8. Number 43, we have 3 times, in this part with the variable. Let's apply the meaning of a negative exponent with that variable portion. This makes 3 over z to the +2. Now the written exercises. It's really the same directions. We're asked to simplify again. And if we have a negative exponent, let's agree to apply the negative exponent rule to use a reciprocal to change to a positive exponent. Number 1, we have a fraction and we're raising to the -4th power. The meaning of a negative exponent is a reciprocal. So let's take the reciprocal of the fraction 1/2. It becomes a 2. And now we have a positive exponent. 2 to the 4th power is 16. Number 3, let's do the work in the parentheses first. 5 plus 2 makes us 7. And now we want to go to the -2 power. Let's apply the meaning of a negative exponent, which is a reciprocal. So we get 1 over 7 to the +2 power. Now take the numerator and denominator and raise it to the 2nd power. So 1 to the 2nd power makes 1, and 7 to the 2nd power makes 49. Number 5, we have a negative exponent. The meaning of a negative exponent is a reciprocal. So take the reciprocal of this number. We get 1 over -3. And now that's being raised to a positive exponent. Look what's going on here. I've done this more than once. I'm removing the negative exponent by creating a reciprocal. And that also changes my exponent into a positive exponent. 1 to the second power makes 1, and negative 3 to the second power makes 9. Number 7, we have a negative exponent, which makes a reciprocal. So now we have 3 over 2, and it's being raised to the positive 3 exponent. 3 to the third power is 27, and 2 to the third power is 8. Number 15, we have some negative exponents. They make reciprocals. So the reciprocal of this one becomes 3 to the positive 2. And the reciprocal of this over here becomes 2 to the positive 2. Now let's evaluate. 3 squared is 9, 2 squared is 4, and these add up to 13. Number 17, we have division. So let's apply the rule about subtracting the exponents. First with the x's. Negative 2 subtract 3 is negative 5. Now let's work with the y's. 3 subtract negative 2 is 5. One of these variables has a negative exponent. The other one does not. For the one that has a negative exponent, let's use the meaning of a negative exponent, which is a reciprocal. So the y to the fifth power, let's leave it alone in the numerator. But the x to the negative fifth, let's create a reciprocal by moving it into the bottom and giving it a positive exponent. Number 19, 2 to the negative 1 creates 1/2 because the meaning of a negative 1 power is a reciprocal. The reciprocal of a 2 is 1 over 2. There's also a 3 down in the denominator, so let me write times 3 by that. Now let's work with the letter a. A to the negative 1 divided by a to the 2. To divide letters, you subtract the exponents. Negative 1 subtract 2 is negative 3. There's also a letter b down in the bottom with a negative 1 exponent. Let's fix those negative exponents. In the top we have a 1. In the bottom we have 2 times 3 is 6. What happens to the a to the negative 3? It changes into a to the positive 3 down in the bottom. What happens to the b to the negative 1 that was in the bottom? It changes into a b to the positive 1 up in the top. So the final answer is a b on top and 6a cubed in the denominator. I'm using the negative exponents to create movement between the numerator and denominator of a fraction. If something is in the top and it has a negative exponent, it moves into the bottom and now has a positive exponent. If something was in the bottom with a negative exponent, it moves into the top and now has a positive exponent. Number 29, let's write as a product. This is sort of like factoring. We're going to write down our x to the negative third power and then follow it up with a set of parentheses that is long enough to include those 4 terms. Now x to the negative 3 times what makes 2x to the negative 3? We need to have a 2 there. X to the negative 3 times what makes negative x to the negative 1? We need to have a negative x. Think of that as a negative x to the 1. And when you times this to this and add the exponents, that would make this negative 2. X to the negative 3 times what makes negative 16x to the negative 1? We would need to have negative 16x squared. Again, times these together in your mind and make sure you agree that it does make negative 16x to the negative 1. A negative 3 plus a 2 makes an exponent of negative 1. Finally, x to the negative 3 times what makes positive 4? We would need to have plus 4x to the third. Do you agree that that timeses and makes a 4? X to the negative 3 times 4x to the third makes 4 because this exponent and this exponent add up to a 0, or you can think of that as cancels away.